So we're going to find vector resolutes now of two vectors here, well, for A and B. So we're going to find the vector resolute of A in the direction of B, and then the vector resolute of B in the direction of A. Now I've got here a little piece of the formulas from your textbook. So here we've got U, A dot B on B dot B times B, where U is called the vector resolute of A in the direction of B. The key thing here is the A and the B, the two vectors you're working with, are a dot product on the top. The indirection part, whichever part is in direction of, that's the part that goes here and also is dot product on the bottom. Okay, I've just included here some other forms as well. The one that maybe you might use more is perhaps this one, because B dot B is the magnitude of B squared, so you could use this one. I'm going to use this one today for these two examples. So the first one we're going to look at here, I'll just do this in light blue. A, we're looking at find the vector resolute of, so vector resolute of A in the direction of B. So it's always a good idea to just set yourself up here with a picture. So there's A, there's B. I'm just making B a little bit bigger so I can then see my parallel vector, which is the vector resolute of A in the direction of B. That's U. So that's A in the direction of B. That's what we're interested in. So what I'm going to do is I'm going to use the formula here. The direction of is talking about B, so that will be the B part and then the dot product underneath. And the two vectors that we're looking at are A and B, so their dot product goes on the top. So that's going to be how I find U. So it's now just a matter of putting in the information. So we've got U equals A dot B, and actually what I might do, let's do the A dot B first. So A dot B equals, now when you're doing dot product, and I'm just going to write out the whole vector here and dot product it, so I minus j plus 2k. When you do dot product, remember that you do the coefficients of I dot together, so that's just the coefficients multiplied together, plus the coefficients of j multiplied together, plus the coefficients of k multiplied together. So we've got 1 I should say, 1 minus 3 minus 2. So we've got there minus 4. So that's your A dot B. B dot B is a similar thing. So again, you've got your B and it's repeated. Now you could also use that alternate formula as well, which is the magnitude of B squared. So you can find your magnitude and then you can square that. You'll end up in the same place. So here we've got 1 and 1 plus -1, -1 plus 2 times 2. So they're the coefficients of I, j and k multiplied together. You've got 1 plus 1 plus 4, which equals 6. And if you were to find the magnitude of B, the magnitude of B is the square root of 1 squared plus 1 squared plus 2 squared. It's actually -1 squared to be correct. And you'd have 1 plus 1 plus 4, so you'd have square root of 6. So this is also equal to the magnitude of B squared, if you want to think of it that way. So now to find our answer, we've got U equals A dot B on B dot B times B, which in this case would be A dot B is -4, B dot B is 6, and B is actually this vector here. So because I'm a bit lazy, I can just pick this up and put it down here. Okay, cool. So that's what U would be. You could, with this as well, factorize this, not factorize it, simplify it. So if you want to simplify, I'll just pick this up and put it onto the next page. It would just be a matter of simplifying the fraction. So we'd have underneath there, divide the top and the bottom by 2. And I've put brackets around that vector part just to make sure that we know that the 2/3 or -2/3 has to multiply the entire thing. So that's your vector resolute of U, of A in the direction of B. So U is the vector resolute of A in the direction of B. Now for the next part of the question, we wanted kind of the opposite, I suppose, which was B in the direction of A. So I'm going to redraw. So for part B, we want B, or the vector resolute of B in the direction of A. So in this case, the picture looks a little bit different. You'd have this kind of setup here, and then you'd be looking at this vector here. So you can call this a different vector if you want. I'm just going to call it U again. Doesn't really matter. And so this time for U, in the direction of is talking about A. So that means that we can put the A over here, and then the dot product of A underneath. Oops. And then on the top is A dot B again. So whatever the indirection of is, it goes here, that vector. So we know from before, we found A dot B, which was -4. So now we just need to find A dot A. And again, you could do the magnitude here of the vectors. Just copy this one. Or you can just do the dot product of the vector with itself, which is what I'm going to do here. So you could stop the video at this point too and finish it off because it's very similar to the one we did before. So coefficients of I multiplied together plus the coefficients of j multiplied together plus the coefficients of k multiplied together. 1 plus 9 plus 1, which is 11. So therefore, for our u, it's going to be A dot B on A dot A times A, which equals A dot B was -4, A dot A is 11, and A is simply this vector here. Pop it down there. Now in this case, there's not really much you can do in terms of simplifying, so I'd leave it like that. So that's our vector resolute of B this time in the direction of A.